Welcome to HIPAA without the headache, simple PHI governance with fine-grained access control. This is a forward-looking statement. I have not looked at it. Please complete your surveys. Leave out the A-B part. All right, my name's Alex Owen. I'm a solutions architect here at Databricks. I'm really excited to be presenting today for the second year in a row with my good friend Vera.
Hi, I'm Veera. I lead data engineering at Hinge Health. We are talking about PHI compliance, how we dealt with it at Hinge Health. Hi, a little bit about Hinge Health. Hinge Health is a MSK platform. Hi, Hinge Health is a digital health platform for pain treatment. We have easy to access mobile app which you can use to do all your PT exercises anywhere and anytime. It is backed by expert PT-led care team. We leverage AI and computer vision as a part of the app to boost the engagement and also to provide effective quality care. Hinge Health has a non-additive pain relief treatment. We also provide 4x ROI on the members who use Hinge Health versus who don't. Overall, our mission is delivering cost-effective quality care with data as a backbone, improving product experiences and operational visibility. All right, let's talk about a little bit about what is PHI and why do we need to be compliant. So any part of, at Hinge Health, any part of health status, care, payment that can be linked to an individual is PHI. And it is governed by HIPAA in overall US, CCPA in California, and we have other regulatory bodies in Europe like a GDPR. Why it is, there are a number of struggles with handling PHI data. We have to understand different regulatory requirements. We have to implement entire data infra to meet those requirements. Second, it is additional cost on infrastructure. So then if you get it wrong, if you take any shortcut, then it can lead up to a few millions in terms of fine. This is really a big deal, especially when you are a growing company and a startup. So there are a number of data entities within PHI space in the Hinge Health context. Some of them we get from externally. For example, we have integrated with EHR systems where we get some of the member data, which could be appointment, which could be their physician's feedback, etc. And the other part is claims, where claims has, let's say, a member or a non-Hinge Health member went to doctor and they did some MSK procedure, so we get all of that data. Eligibility, Hinge Health has a member business to business model, where what that means is, let's say you have an employer, that employer has to provide Hinge Health as a perk. So once that happens, we get all employees' information from the employer or the insurance. And rewards, as members perform activities on Hinge Health, we have some clients who would like to provide rewards to their members or employees. So we get all of that data. Internally, throughout all of member interactions have PHI data. For example, as you use the platform, we have several questionnaires injected as a part of the workflow, where we want to know your current condition and how it was before you joined Hinge Health, once you perform an exercise, all of that. Then exercise therapy sessions, so we have several sensors. So once you talk to coach on the platform, they recommend ET, exercise therapy sessions where you have to perform some exercises. So we capture all of that. And then if you use sensors, we have sensor data. Messaging, all the interactions to the coach happens, it happens via text, video and audio. So all of that is considered PHI and it's all captured. So, okay, you have all of that data. So why it is a big deal? So we had one unique challenge. During COVID pandemic, there was a huge demand for Hinge Health platform. So as a result, more people needed virtual care. So in order to provide care for more people, we had to build more features. So in order to build more features, we needed a bigger team. We expanded our hiring within US, we made it remote, but everyone was hiring within US. So we ran into talent crunch. To keep up the pace, we had to think globally. So we expanded our hiring efforts to Canada and India, unlocking new talent pools that have helped us maintain product development momentum and grow our team across the time zone. This global approach became key to scaling platform quickly, reliably, when it mattered the most. This also led to this problem statement, which is scalable PHI governance to enable strategic hiring, fuel business growth, and drive AI innovation. So little bit, this is the entire this is the journey of our entire PHI, how we are storing and what we are doing about it. Little bit background. In 2022, we started migrating all of our data to Databricks. The previous version of data warehouse was Postgres based. So we were around nearly 15 terabytes, and we started hitting a lot of challenges, operational challenges in maintaining it. So we decided, okay, it's a time to move. At that time, we decided to go with Databricks, and I think at majority of 2022, we focused on building the data ingestion pipelines, essentially a platform. As we started, I think once we started getting the data into Databricks, our users and all Databricks users also grown significantly. It was like we grew as a company, and it was like a hockey stick growth. So one of the challenge was we had to implement some framework where we can provision the users and also provide access. And so as a solution, I would like Alex to talk about it.
Okay, so Unity Catalog has been a big part in the PHI journey at Hinge Health, and I think to understand the true value of Unity Catalog, it's helpful to envision Databricks without it. So let's think about every team needs some environment isolation from a dev stage prod perspective, and we implement that in Unity Catalog, or Databricks rather, with separate workspaces. And so each locally scoped workspace has some user management functionality, has a Hive metastore to manage our data, and then we also have some compute, so clusters, SQL endpoints, and things like that. And so this has some inherent problems right off the bat. So since we're locally scoped, user management is duplicated between workspaces, and then each workspace might have a different definition of user management, so we have an inconsistent governance policy. The second problem, you guessed it, there's a silo. So we created some data silos between workspaces. That makes it difficult to discover data. That makes it difficult to collaborate on data, and it certainly makes it difficult to manage PHI. So Unity Catalog, on the other hand, manages all this stuff at the account level. So we have a single unified governance layer on top of all of our workspaces. And then from a metastore perspective, we can now share this data to each workspace based on RBAC. Unity Catalog also has a 3-level namespace, so think catalog, schema, table, and that lets us discover domain-specific data, it lets us collaborate, and most importantly, it lets us flag PHI at a pretty high level. So now that we have moved our user management and our metadata to the account level, and we can inherit different groups and user permissions in each workspace, we can start doing some really cool things like streamlining onboarding. So now we're going to integrate Unity Catalog groups with our Okta groups. And this allows engineers who just joined the company to become immediately productive in Databricks. So as we're onboarding new engineers, we don't have to onboard them to Databricks as well. It just syncs, and it's this really streamlined process. There's some other really cool benefits from this, is that we can start enforcing Okta governance principles in Databricks. And I'm talking about like password complexity or multi-factor authentication. And so this has been really able to move the needle at Hinge Health, especially as they're trying to rapidly grow their teams.
All right, so I'm struggling with the two screens. So imagine we have two workspaces. One is HIPAA, one is non-HIPAA. Just imagine I'm struggling to present here, but imagine we have double the compute. We have to provision ML compute, compute for analysis, compute for ETL, compute for ad hoc querying, ad hoc fixing, and then we have to copy some of the, by default, all data lands into PHI space. So then, because of the team we have where they need access to non-PHI, so we implemented a process which would identify what is non-PHI, and it copies data into non-PHI space. So what this means is we have to maintain those processes, and we have to run those processes. Some of them as frequent as every few minutes as soon as the data lands. So what that means is it is also cost to run those. So the other challenge was we embedded some of the fine-grained data masking as a part of ETL. So as we copy this data into from PHI space to non-PHI. So it was not easy, but we had to make it, but that had a lot of challenges.
Okay, so workspace catalog binding is a governance feature in Databricks where we can associate individual catalogs to only a workspace. And this has some pretty great benefits where you can isolate PHI data only to the workspace that needs it. And you also have some extra confidence that you're not leaking out PHI by mistake. And so the implementation at Hinge Health for migrating from these locally scoped Hive metastores to Unity Catalog looks something kind of like this. So the first thing we do is we move users, groups, and service principals up to the Unity Catalog level, and then we're going to take two catalogs, yes PHI, no PHI, and then we're going to start migrating those locally scoped Hive metastores up to Unity Catalog. Once we have the data securely in Unity Catalog, we can expose non-PHI to all the workspaces in a consistent fashion. But we need to bind the PHI sensitive stuff to the prod workspace where we know we're going to be processing it, and that way we have a smaller blast radius when we do need to expose this data. It's sensitive, and so just to very selected groups. So once we've migrated all these things up to Unity Catalog, we've bound the workspaces, we can decommission the Hive metastore, and we are a Unity Catalog only shop. Pretty exciting. This was actually like, we had a party after we did this. This was a big deal. Okay, so now that we have a coarse-grained strategy, we need a fine-grained strategy to complement it. So row-level security and column masking is a way to restrict data from users based on their identity or the group that they belong to. So with row-level security, we're simply restricting the return rows of a query, but with column masking, we're trying to redact all or some of an individual column. And typically, this is implemented by two separate functions that are based on the identity. So let's take a look at this example. We have Alice, who works in the HR department. She's a member of the HR group, so when she queries sensitive data, she sees all of it. But when Bob, who is not part of the HR group, queries it, we're gonna have column masking redacting the social security number. In the email, we can only redact the sensitive parts of it, and we can also provide null values as a result of the function. Also, when Bob queries, the sensitive rows will be filtered out. It's also an important thing to note that neither Bob nor Alice own this functionality, right? So this is a situation where Alice would go to Vera's team and say, hey, this is the data that we need to expose to my team, but not anyone else. Can you please implement something for us so we can kind of enjoy the benefits of this fine-grained access control? So the first iteration of doing this was in Hive. So again, we have these isGroupMember functions, which is really cool, but it's workspace local. And so we're creating a row-level filtering based on the manager user group, so they can only see contracts over $1 million, where the auditors can see the full email. Otherwise, we're going to abstract or anonymize some of that. And so this has a couple challenges as well. Again, workspace local, so we're dealing with group memberships that may not be consistent between workspaces. And so that creates a governance headache because it is inconsistent. There's also a tremendous management overhead of every time the data changes or business logic changes, we have to go manually find the blast radius of this PHI and manually change the views. And that management overhead just was really preventing Vera and his team from scaling and meeting their business objectives. And then finally, there's a performance tax that you hit when you're creating views on every table or joining multiple tables together. And again, those joins could only be within the individual workspace. So a lot of challenges was implementing this in Hive. All right, so we're gonna go over to the Unity Catalog side of the house. And again, we're gonna be using this same kind of isMember functionality function. And so, but these are at the account level. So now we have consistent groups, And we're able to, again, implement this with standard SQL, but the real difference is we're creating functions, not views. And so these functions are something that we can apply over different workspaces, over different tables, and in multiple columns in the same table. So again, we have something that's easy to use, everyone understands it. It's something that's globally scoped, so it's consistent. And also there's not that, that performance hit by creating yet another database object to manage. And so this is really easy to just simply associate these functions with a table or a column with an alter table statement. And funny enough, you can actually you have access control over the functions themselves. So there's user groups that can create functions, there's user groups that can use functions, and there's user groups that can't see the functions at all. So pretty interesting, and this really moved the needle and helped Vera's team move quickly because we weren't managing so many database objects.
So imagine, I think this is really huge. Imagine where you are tying the mask policy with the role, and regardless of how the data gets accessed, whether it is by analytics cluster, ETL cluster, so this just locks it. So yeah, one less headache is gone. So the next problem was we started landing all the data into Databricks. So a lot of our consumers started asking, hey, where can I find the questionnaires which you saw? Where can I find the users or members ET session details or sensor data? Like imagine we have thousands of tables. So as a team, if it is 10 table, a single team can go in and look into the table attributes and also the data and provide, okay, this is where you go and this is how you use. But imagine doing that for 1,000 tables. We needed to scale. So that was one problem. Second, as we built processes, we needed some sort of access and audit logs. For example, we needed a process where to inform compliance if somebody comes and asks us who accessed this data and when and how often they accessed. So all of that was captured in the cluster logs, but it was very, very complex and manual to get that information. Second, as we are building the platform, we always want to optimize the processes. So it was very challenging to identify which processes are taking the most time and where we need to optimize. So those two were the key challenges as we grew our platform. So as a solution, Alex?
Sure. So one really important part of a PHI strategy is collecting and using the right metadata. So there's a couple ways that we can, I want to break this down and kind of help you understand the different aspects of where we're collecting it and how we're using it. So table properties. This is where we can add PHI descriptions to table comments that live as table properties next to things like file location and file format and optimizations. And all this stuff shows up in our auditing, in our audit logs, in our automation. So it's surfaced through these kind of more global workflows. Next, and this is probably most important, discovery tags. And this allows us to not only quickly discover PHI at the column level or table level, but we can tag clusters and workflows so we know where PHI is being processed. Now we kind of shift gears into looking at things from a catalog, single source of truth perspective. So Unity Catalog provides telemetry tables at the account level that surfaces a lot of metadata around ownership, permissions, and even column level. So now we can start auditing things at the column level. We can see relationships and patterns between all these different players. And then finally, we have another table that sits at the Unity Catalog level as a single source of truth for tracking column lineage and table lineage. And so this is key for tracking PHI flows across pipelines, across notebooks, and it's critical to know where PHI is going and where it originated. So let's talk a little bit about centralized auditing. And again, I think it's helpful here to envision a pre-Unity Catalog world. So with audit logging, it was based at the cluster level. So we have some cluster logs, and we have to download those to S3, create yet another pipeline to make them usable for our compliance reporting. And we have to do this for every cluster we have. And this just simply doesn't scale. Unity Catalog, on the other hand, has system tables, these tables that collect telemetry from almost all aspects of the platform, where we can start querying by user activity, access timestamps, access descriptions, even environment changes. And this unlocks more robust reporting, the ability to make dashboards, set alerts, and even get insights from LLMs. And I think one important caveat here is when you're working with PHI, it's not enough that you're auditing it and your team knows you're doing the hard work, you need some kind of vehicle to communicate that you are doing the right things to stakeholders, board members, and executives. Because it's one thing that Vera's team is doing all the work, but if no one knows it or has confidence, it's kind of all for naught. Okay, system tables are so cool. They're one of my favorite features. I think they deserve another slide, right? So we're able to connect the dots between all these different parts of the platform. So I'm thinking like auditing, lineage, query history, and all the tables that roll up for orchestration. So if we map our ability to query and easily use system tables with SQL that pretty much everyone understands, I want to map that back to the impact, right? So I'm talking about querying by user action, all sorts of metadata. We can map our data access back to the individual data sources, the catalog, the schema, users group, service principals, workflows, and then most importantly, tracing that PHI through the system. And that unlocks like really good monitoring, auditing, alerts. We can start really doing proper analysis on this data, not just simply reporting on it. We can automate painful tasks that were unthinkable to automate 2 years ago. And then finally, we can start interacting with these tables with natural language with some of our AI BI features in Databricks. I'm thinking like AI BI dashboards. So I can't understate the importance of system tables here.
All right. I think we implemented so far all of this. So now our current challenge is, imagine we have thousands of tables. When we started Databricks journey, we started with around 15 data coming in from 15 to 17 data sources. Now we are at hundreds, if not more. And as a result, we have at least few thousand tables. So imagine tagging those tables. Okay, which one has a PHI, which one has a PII, and what other additional tags like questionnaire tags, exercise tags, member data versus eligible data. So it's a lot of work going through all of those tables. So as a solution, so far what we have done is it's all manual work. Like we have identified few sets of tables, we have done the tagging, but it is very manual. But I think we are definitely looking forward to process where we can tag in automated way. So yeah, I'll let Alex talk about next one.
Okay, so I think Hinge Health has a great PHI governance story, but we're still relying on static roles and groups, and we want to adopt, as a forward-looking organization, we want to adopt something that's dynamic and flexible. So we want to start working with attribute-based access control, and that allows us to look at the attributes of both data and users and work with that together to make a more flexible and dynamic management story. And this isn't something that we're going to throw RBAC away. It's definitely, RBAC is a great foundation that we want to build on top of. And so when we think about how ABAC is implemented in Unity Catalog, it's 3 pillars. We have our attributes that describe data and users. So most importantly tags, but we can start thinking about job responsibility, location, time sensitivity for access. Then we also have some policies, where this is just conditional rules that define access based on the attributes of the data and the user and possibly the time. And then finally, inheritance. And this is the most important one because this allows us to operate at scale. So we can pass those rules down a hierarchy and they coexist right alongside RBAC. And so let's think about an example like this. So we have a catalog that has a very permissive access pattern. And then we have a schema, and we're going to apply a rule on top of that schema. And then for every table that has PHI tagged at the column level, we're going to apply our column mask. So this prevents us from touching every table, prevents us from touching every column. We can set this stuff at a higher level and let the hierarchy and the inheritance take over. And so if we want to implement this with code, it might look something like this. So we're going to set our policy called column mask. We're going to set it on the schema, sales prod. We're going to leverage our existing masking function that we talked about a few slides ago. And we're going to roll this out to all users except for PHI admins. And so when the columns are tagged with PHI, we're going to apply our column mask. And so ABAC is something that we're going to tackle in the next quarter, but it's something that can really help us work at scale at Hinge Health. Next, data classification. So we've made some pretty big strides moving from the Hive viewpoint of the world to the Unity Catalog viewpoint of the world. But there's a couple pain points. So when new data arrives or new data elements pop up in existing tables, it's still super painful and manual to one, like evaluate the blast radius of this PHI and what to do with it. So we have to go back to the drawing board and say, where's the PHI, what's going on? So the Databricks Unity Catalog approach to this is to provide automated classification and tagging. So we're going to scan these tables and let an LLM decide what is PHI and what is not based on some established patterns. So we're going to automatically scan these tables, we're going to classify it, we're going to add these tags without manual intervention, then we can use those tags in RBAC and ABAC. And so I want to reinforce the pattern here as we've gone through the journey with Hinge Health, is that we're never going back to reinvent the wheel. We're never deprecating old stuff we don't need anymore. We're building a solid foundation and we continue to build on top of it until everything's automated, except me, of course. Another cool thing about data classification scans is they're optimized for cost and performance. So they keep state. So you're only scanning newly arriving data. You're not scanning the whole table every time. And even when a table is scanned is decided on an LLM that's running under the covers. Each scan comes with a data dashboard monitor, so you can see how PHI is changing over time, and you also get notifications when sensitive data is arriving. And so since these are suggestions based by an LLM, you also have the freedom to accept those suggestions or change them later, which is, I think, a pretty important part of this. So these are all kind of, these last two, ABAC and data classification, are the things that we're going to tackle in the future, and I'm really excited to keep working with Veera and his team.
Thank you, Alex. So few key takeaways from 2022 all the way until now from PHI perspective. Non-standard way of solving costs more. Everyone knows in general data infrastructure costs a lot compared to the application stack, because we have to maintain all data for a given company and it is constantly changing. We have to stream all changes and etc. So in this case, what we did was, when we didn't have the masking capability, we implemented views and processes where we copied the data from PHI space to non-PHI. So it was not standard, but we went ahead because that was the need of the hour, but it ended up costing us some money. And there were few other things we did which was not standard, so that ended up costing more on Databricks infra. So like always adapt to the best practices so that you want to keep the cost low. Second one is leverage native tooling. As we rolled out, in one of the challenge was consumers started asking, hey, where can I find questionnaires data? Where can I find exercise data, sensor data? So we went ahead with one of the vendor to manage our metadata. But the challenge there with that tool was there was no automated description population based on the data that we have. And team had to manually generate all the tags, information, what table means, what data source, what does it mean from product context, from data context, and we also had to do that for every column. So imagine doing that for thousands of columns, so it is not scalable. So that is other key takeaway. Wherever possible, adopt dynamic processes. Don't build processes for table specific or set of table specific. So try to build a masking capability, define the mask for a given column and apply it to wherever it lives, so that all the roles can leverage that. So try to build dynamic processing. And the last one, which is very important one, is iterate and build on existing functionality. Focus on the foundational work. Like for example, when we started implementing Databricks, we started with provisioning. All the provisioning would happen through Terraform. So fast forward 3 years, we don't worry about how things get provisioned. We don't worry about who changed what cluster configuration. And we went ahead with Okta. We don't worry about now how the user got the access to particular data set or particular table or compute. Then, yeah, I think focus on the foundational things instead of building one-off solution. That way you don't have to worry about it few years down the lane. So the entire data engineering the state of current data engineering at Hinge Health, it wouldn't have been possible with the great team we have at Hinge Health. Special shout out to Raja. He is one of our staff engineer who led the Unity catalog migration and has been adding features on Databricks. Yeah, with that, thank you all for
Thank you so
everyone
much.
for coming over.